and it tells us to have a force of 1,000 newtons. And, all right, let's click OK. And as you see, it makes this. And one thing with that, actually let me go into those loads. So it has angle 180 degrees. So what that means is it's going to distribute this negative y-axis load across 180 degrees. So it's actually pushing everywhere from here all the way around to here, if that makes sense. And that's why there are a few arrows, because it's showing that there are arrows going along that entire face. And if you look at the picture in the lab, in the tutorial, you'll see there's even more arrows in their case. And so then under this bearing load, you can also edit the display. So if you right-click here and say Edit Display, you can even, it says you can change the scale of these, so you can make it larger, and they're, you know, just the size of the arrows if it's too big or too small. So I'll just leave it like that. All right, now we want to apply a constraint to this face right here. So on constraints, it has us select a pinned constraint, and this is the surface. And let's see, I think that's all we need. Okay, and there we can see it's made a lot of constraints on that surface. Now it wants us to apply a second constraint, and this one it's going to be a user-defined constraint. So user-defined constraint, and it's going to be by default an SPC, and displacement CTS will be existing, type filter, define, and the object where it wants us to do it. If you zoom in to this point right here, you'll see there's a point right there. So that's where it wants us to put the constraint at, and it tells us to fix the degree of freedom 1. So we're going to fix degree of freedom 1 and leave the rest of them free. So we click, that's all right, let's see. Yep, so we click OK, and there it's create another constraint. Now if you notice, this is very similar to the tutorial in HyperMesh, where we constrained the back end of it, put some loads on the front end, and put another constraint right there in the middle. So then we can save the model, but that's not necessary. But when you do it, you're going to want to save just in case. So back in Simulation Navigator, if we go up to, so we're in this, and we go to Solution 1, and if we right-click and say Model Setup Check, then it'll run a setup, which is similar to the check in HyperMesh, and it says that it's completed and there are no errors or anything. So you can just close out of that. And now we need to request the solution output. We want to tell it what we want, what kind of results, what kind of outputs we want to give. So this, follow this carefully. It's in, it shouldn't be too hard to follow, but I'm going to do it here. So on Solution 1, if you right click and say Edit Solution, or I think just Edit. Right, there we go. So it says Edit Solution, but it's just Edit. And then it says to go to the Case Control tab, and here, oh. And if you scroll down to, or it'll probably be on your screen, Output Requests, and it says Modify Selected. So you're going to want to click this button, which is Edit. And that will bring you to this menu, and then it tells us to select the Strain tab, and then we just simply have to say Enable Strain Request. And there's a lot of other stuff there, but that's all you have to click. Okay? Okay. So now we've requested it to give us the strain. So now we're ready to solve the model. So now you just right-click on Solution 1, and we say Solve. And okay. And now it's running. And this one will go a lot faster than HyperMesh. This one goes very quickly. Or OptiStruct it rather, it's one that solves. All right, so this is all part of the solver. It pops up, it brings up these three menus. So when it's done, it will tell us when it is finished. Are there any questions up to this point? I haven't asked. Good. All right, so now it says job finished, so we can just close out of all these, close out of this. We can exit the information and hit cancel. And now we're ready to view the results. So in the simulation navigator here, we now have a results tab. So if we double click on results, it will bring us to this tab, which is the post-processing navigator. And we can expand solution 1. And it says we should expand strain, elemental nodal, and take a look at the von Mises. There we go. So there are the von Mises stresses going on in this simulation. And now it wants us to look at the displacement nodal and click on Y. So here's the displacement that occurred under this simulation. And that's basically it. There we are. That's everything. Now the last thing I want to go over is how to create a simulation report, because now that we're done, we can create this report. So the first thing to do is if we go back to the simulation navigator and you right click on solution 1 and you say set up report. And now it has made a report. And if we look at it, this report has a lot of information. And then to add images to this report, if you scroll down to the bottom here, and there are images. So if I position this like I want it to, and under this, not this folder images, but this icon images, and you right click, you just say snapshot. And it'll take a snapshot of the screen and add it to your simulation report. So we should probably also include one of the von Mises stresses that were there. And so we go back to here and we say snapshot, and now we have 2 images in that simulation report. And then to export it, you just right click on the report up here and say export. And it'll create an HTML of our result. So this report now has all this information about the simulation and whatnot, and down at the bottom we have our images that we have saved. So you're going to want to make this into a PDF. You can probably just copy all this text into Word. You just select all and copy and paste into Word and then save that as a PDF. That's probably the easiest way to do it. So that's basically it right there. Does anyone have any questions up to now?
I got the report. I'm trying to resolve it.
Yeah, I can come help you individually right now. Is there anything else?
You can always just print it to a PDF printer.
Right, that's another good thing to do. Yeah, so basically once you get to here, you can figure out how to get it to a PDF. We're not doing any tutorials on that. No, thanks for help. All right, okay, great. We'll be walking around helping you. And look at that, that took me 10 minutes, maybe 15. So make sure you do the same thing with the other part, the lower control arm of Lab 4, and basically just run through the same kind of simulation, put some loads on there and some constraints, and make a simulation report as well.